Alright, so in this problem here, we have a circuit with 4 light bulbs on it. And the first thing you're asked is to calculate what the potential energy change of an electron as it moves from the bottom of the circuit to the top of the circuit would be. Now, it says point from Z to X. So Z is connected to the negative side of the battery, X is connected to the positive side of the battery. So our voltage difference that the electron is going through will be this entire 24 volts of the circuit. So to find the potential energy change, we look at our potential energy formula, which equals QV. So we know the charge of an electron is 1.6 times 10 to the negative 19th coulombs. Remember that this the negative sign on the electron indicates direction. In this case, I'm not really worried about direction because energy is a scalar object, or a scalar quantity. Alright, our voltage difference we're going through here now is 24 volts. So 1.6 times 10 to the negative coulombs times 24 volts will give us an energy change of 3.84 times 10 to the negative 18th joules. Alright, and you're asked to see whether the electron gains or loses potential energy as it moves from point Z to X. Now, here's my little sketch. If you're at point Z, how about a nice green color? So if we're at point Z, my electron is close to the negative end of the circuit. If I move to point X, it's close to the positive. Now electrons want to go from negative to positive, so what will happen is that as it gets pushed, it will accelerate and will lose potential energy. I'll erase these little circles right here. Let's go back and let's say loses potential energy. No, still green. Alright. The next thing it says is to calculate the equivalent resistance of the circuit. So, we have a circuit here. 6 and 3 are in parallel, 12 and 24 are in parallel, and these two and those two are in series. So if you have to build yourself a plan, my plan would be, 1, let's number these. They're labeled. Let's convert A and B in their parallel. My second plan would be to convert C and D, which are parallel. And then my third option would be to convert AB and CD, which are going to be series. So, you see the values, I've already done it here, but to convert these two as parallel, you would do 1 over 6 ohms plus 1 over 3 ohms equals 1 over RT. In that case, it becomes 2 ohms. Then 1 over 12 ohms plus 1 over 24 ohms equals 1 over RT. In this case, that RT will be 8. And then to calculate what the total resistance is, these two and these two are in series, so 2 plus 8 is going to be 10 ohms. Hopefully y'all can see that. Alright, and it says to indicate on the diagram the direction of the current through point Y. Now, you should know that current flows from positive to negative. So since our positive is up here, the current will go up this way, over this way, and down. So at point Y, our current will be going toward the right as it flows down towards Z and finally back to the battery. Alright. Next thing we want to know is calculate the energy dissipated in the 12-volt bulb, or excuse me, 12-ohm bulb in 5 seconds. So for this, it may be useful to draw a VAR chart. So if we draw our chart, we have A, B, C, and D in our total. So V, I, R. So A is going to be 6 ohms, B is 3 ohms, C is 12 ohms, D is 24 ohms, and our total is going to be 10 ohms. We saw that earlier. Total voltage is 24 volts. So if we solve for a current, 24 divided by 10 is going to be 2.4 amps. Now, next we need to do is figure out what the voltages and the currents through everything else are, because we want to find what the energy dissipated is. We need to know the current, or at least the voltage. So if we go back to our chart right there, we have 24 volts across these two right there. We know our equivalent resistances of each of these values here, and our total resistance. Now, since these right here is our series, when they're combined in these values here, I can see that V equals IR. So if I multiply each of these by my 2.4 amps that I solved a minute ago, I get that 2 times 2.4 is going to be 4.8. And that's the voltage across these two right there. And the 8 times 2.4 is going to be 19.2, I think. Yep, 19.2. And I can go and plug these in here. 4.8, 4.8, because those are parallel, and then 19.2 and 19.2. And I can solve for each one of my currents as well if you want to. Just might as well, just for the sake of filling this chart in. So this right here will be 0.8 amps. This will be 1.6 amps. This will be 1.6 amps. And this will be 0.8 amps. So if we want to know we're asked the energy dissipated in the 12 ohm bulb in 5 seconds. So the 12 ohm bulb will be resistor C. So let's figure out what the power of this bulb is. So power is given to us by P equals IV. So our power for that 12 ohm bulb, this one here, is going to be 1.6 amps. And our voltage across that bulb will be 19.2 volts. And this gives us a power of 30.72 watts. Now, we're to ask for how much power is dissipated in 5 seconds. Well, power, a watt is a joule per second, so power times time equals pure energy that's dissipated. So our power, which is 30.72 watts, multiplied by our time, which is 5 seconds, will give us a power of 153.6 joules. The next thing we have to do is rank these right here in order of brightness. Now, this can be kind of tricky, because how do you know how bright a bulb is? And the key to that is to look at the power that's dissipated through the bulb. Let me clear this up a little bit for you so y'all can see. Alright, so you should know that a 100 watt bulb is brighter than a 50 watt bulb. So to determine the power, what I would do is figure out what the power, or to determine the brightness, I would figure out what the power through each of these bulbs are. We can use P equals IV for that. So I'm going to put a new column, a P column for this chart, to determine the power for each of these bulbs. So the first one will be 3.84 watts. The second one will be 7.68 watts. We saw for the third one a while ago. It was 30.72 watts. And our last one will be 15.36 watts. So to determine the brightness, all we have to do is rank these in the order of their power, which will be C, D, B, A. So in your sheet, I think it has it written as A, B, C, D. So all you have to do is say well, that's not right at all. So it will be 4, 3, 1, 2. Just in order of the brightness.